There. The integral from a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to a of f of x dx for any c. And c has to be in the domain of f. So there are three cases for the proof. Case 1, the easiest case. C is actually between A and B. So we have A, we have B, and in the end, we want to know the area from A to B. Well, of course, if C is in the middle, the integral from A to C of f of x dx, this area is additive, plus the area from C to B of f of x. Oh, look, that's the area from A to B. This is equal to the area from A to B of f of x. So in case 1, we got what we wanted. Okay, now let's look at case number 2, where, say, C is less than A. So our picture looks a little bit different. We still have the same area that we want, but we go to C. Okay, so now the integral, so the graph goes further. So the integral from A to C of f of x plus the integral f of x dx plus the integral from C to B of f of x dx. So let us see what is going on. F of x dx. Now, plus. Now, what we can do is, well, it's plus this, the integral from C to B of f of x dx, plus this. But if I change the limits, it becomes minus f of x dx. So let us see what's going on. This here says find the area from C to B. Okay, that's all this area. Ooh, that's a little bit too much. I only want the area from A to B. Take away the area from C to A. From C to A, take it away. Bingo, we get the area just from A to B. A to B of f of x dx. That is, this sum is equal to that. That's all we wanted to show. Now, case 3, suppose that C is all the way to the right. So we have our same integral from area from A to C. We have our same function. And let us see what is the area from A to C of f of x dx plus the area from C to B of f of x dx. Now, I like the lower limit to be less than the upper limit. C is bigger than B, so I immediately reverse that. This is the integral from A to C of f of x dx minus the area from B to C of f of x dx. Well, let's see what this is. This is the area from A to C. Okay, from A all the way up to C. Hey, that looks pretty good. It has the area that we want from A to B. It has it, but we don't want that. Well, don't worry about it. It says to take away the area from B to C. It says take all of this away. Well, we're left with just what we want. The area from A to B. This is equal to the area from A to B of f of x dx. So, in all the cases it works. I guess maybe there's two more cases to look at. Suppose case 4. Suppose A is less than B, but B equals C. Okay? B equals C. It equals one of the endpoints. So, the integral from A to C plus the integral from C to B dx, oops, let's break down a little bit more than that, f of x dx plus the integral from C to B, integral from C to B of f of x dx, well, this is equal to the integral from A to B plus, that's B, of f of x dx. So let's write this on the next line. This first integral is the integral from A to B of f of x dx plus the integral of x to b plus the integral from b to b of f of x dx. That's 0. So we just get that. We get the integral from A to B of f of x dx. Now, possibly I'll have enough room to sneak in case number 5. That's when C is equal to A. Okay, so we have the integral from A to C of f of x dx plus the integral from C to B of f of x dx. This first integral goes from A to A because C is A. That's our assumption. Plus the integral from, instead of C to B, C is A. So it's A to B of f of x dx. F dx. But this integral going from A to A is 0. And when you add 0 to that, you get the integral from A to B of f of x dx. And you get exactly what you wanted. And this is true for all cases. So now you should say combining all the results, we have the integral from A to B of f of x dx is equal to the integral from A to C plus the integral from C to B for any value C. I know, we proved it for each and every case, which is pretty neat that it works. So now you can use that anytime you want because